This activity is entitled tiling using regular hexagons and equilateral triangles. The objective of this activity is to explore how regular hexagons and equilateral triangles can be arranged to cover a surface without gaps or any overlaps, and start understanding the concept of tessellation, that is tiling, which is a very important thing in geometry. Let's understand the concept behind tessellations first. So if you see, an equilateral triangle can be placed adjacent to another equilateral triangle like this, and we can continue this pattern to any extent. So if we have a big surface, we can actually cover the surface using this pattern of equilateral triangles, and there will not be any gap between the triangles, and therefore an equilateral triangle is said to form a tessellation. Likewise, if you have a regular hexagon like this, you can place a number of regular hexagons having the same side like this, and you will find that there is no gap which is left between them also. But if you try with some other polygons, it might not work because of the gaps or overlaps which exist when you try to place them adjacently. Let's see what is the material required to perform this activity. We require cutouts of 12 equilateral triangles, then cutouts of 3 regular pentagons, cutouts of 3 regular hexagons, colored pencils, graph paper or plain sheet of papers, and then the regular things like pencil, ruler, eraser, etc. Let's perform this very interesting activity of tessellations now. To perform this activity on tessellations, as you can see in the observation table, we have serial number 1, in which we will be using a particular shape. We will be finding how many sides are there in that particular shape, and then what is the measure of each interior angle, and when you arrange them at a junction, will there be any gap left or not, and what is the observation. So let's take the first shape. Here you can see we have cut so many equilateral triangles, and therefore in the observation table we need to write equilateral triangle in the first column here. So in the first shape, equilateral triangle, obviously the number of sides in each triangle is 3, and therefore if you count the sum of interior angles, this is 180 degree, right? So 180 divided by 3, your each interior angle will come out to be 60 degree. Now we need to arrange these triangles to form a tessellation. Let's see whether we can actually arrange them or not. So if you arrange the first triangle like this, and second one adjacent to the first one like this, they exactly fit into each other, but we need to see if a gap is left or not. So let's place the third one like this, the fourth one like this, and you see they are exactly fitting into it. Now this is the fifth one if you place it like this, and sixth one if you place it like this, and see what is the result. They exactly fit into one another. So the students are advised to cut these triangles and then paste them in the lab manual, so that they will see that there is no gap left on the junction. So gap, yes or no? No, there is no gap, and observation is that a tessellation is formed. Tessellation is formed. This is what they write in the observation table. Now similar to these triangles which are equilateral triangles, they will pick up the pentagons. Now we have some cutouts of the pentagons. So in the observation table they will write regular, that means all sides are equal, pentagon. And now the pentagon obviously has 5 sides and the interior angle is 540 by 5, which is 108 degree. Now they have to try to arrange these pentagons to form a tessellation. So let's see whether a tessellation is formed or not. If they place two of them like this and they try to place the third one like this, see what happens. We have arranged the three, but at the junction you have a gap which is left out and you can't put the fourth pentagon in this gap because this angle is very small as compared to the angle of 108 degree, and therefore gap, yes or no? Yes, there is a gap, and therefore the tessellation is not formed. That means you can't arrange the regular pentagons to form some figure which has no gap. And similar thing you can do with the hexagons. Now as you can see, we have hexagons here. So in the observation table you can write regular hexagons, and then the regular hexagon has 6 sides and the measure of each angle is 720 upon 6, which is 120 degree. And now we will try to arrange them to form a tessellation. Let's try. This is the first one. This is the second one. I can place them like this. And the third one, does it fit into it? It absolutely fits into the first two hexagons. And is there a gap? There is no gap. And since they fit into one another at the junction, therefore a tessellation is formed by the regular hexagons. And that completes your activity on tessellations.